And so maybe to kick us off here, I'd like to start by introducing myself. My name is Luke. I'm with Micromobility Industries. We're a media company and event series focusing on the future of transportation by small electric vehicles. This is part of our regular webinar series we do, focusing on in-depth industry topics, really designed for professionals, entrepreneurs, founders to get a better sense on where the industry is going, what the key business trends are, and how to orient your strategy in sort of the shifting environment. Today, we're talking about how connectivity can help pave the way for increased profitability in micromobility. As you can see on our title slide here, we're joined by great panelists from Monogoto, from Romer, from Wiz. We'll talk about them in just a moment. But I think it goes without saying that the micromobility industry really can't exist without connectivity. When our founder Horst Deju coined the term micromobility, connectivity was always part of his original vision, that these are computers on wheels or smartphones on wheels, as he liked to say. And so, the ability to be able to, get real-time insights on these vehicles is not only crucial for the user experience, also crucial for the operator experience. So we'll be talking about the ability for operators to be in the driver's seat when it comes to fleet connectivity and getting real-time insights, including notifications, the status of vehicles, and how all of these kind of factors contribute to the bottom line and profitability, which I know is so important to our industry right now. So without further ado, I want to kick things over to our really esteemed group of panelists here. We are joined by Jeff Blaisdell from Romer, fleet management and software solution platform, which we'll talk about in a second. Itamar Kunik, the CEO of Monogoto, which is a connectivity provider, which we're going to hear all about in just a moment. And Tanya Kashina from Wiz, who is here to help to kind of shed light on her experience operating electric bikes in the delivery space as a fleet. So it's really a great mix of people. We're really excited to have you all here. And without further ado, Itamar, would love to start things off.
Thank you so much, Luke, and thank you everyone for joining. We're very excited to speak with you today and share with you some of the challenges that we see in the path for profitability. So what we'll do today, once we'll do a short round of intros, we'll show some high-level statistics on the field, mention some of the major obstacles and challenges on the path to profitability, and understand some of the underlying reasons. And then we'll talk about connectivity, software-defined connectivity, and how you can benefit by switching to software-defined connectivity and the impact it can have on your fleet. So let's get started. We'll start with some intros. Tanya?
Yeah, so my name is Tanya Kashina. I'm very excited to join you today, and I'm the head of supply at Wiz. We provide e-bike rentals on monthly subscription basis in New York City. We currently operate in a fleet of thousands of e-bicycles across all over New York, and I'm the person responsible for the supply chain, so sourcing different components and making sure that they come assembled as a ready-to-go bicycle, which is ready to hit the streets of New York. And also one of the core components of the bicycle is the IoT model for GPS tracking. So so I'm really interested in all the solutions present on the market and dig deep into finding the best solution for our fleet, which we are currently using.
Thank you so much, Tanya. Jeff?
Hi, this is Jeff Blaisdell. Thanks for having me today. I'm currently the founder and CEO of Romer, and we're a relatively new entrant into micromobility. We have a fleet management solution that we've acquired and started up over the last year or so. One of the things that's interesting for me is kind of contrasting and comparing my 30-year experience in financial services with now starting a micromobility startup. And one of the big similarities between the two, and I'm a little bit surprised at this, is the complex nature of the systems and the fact that a lot of things have to come together to work really well, both in my experience in financial services and in micromobility. One of the biggest challenges of micromobility when compared to something like financial services is the margins. And whereas financial services companies generally have quite large margins and can spend lots of money on technology and solving problems, micromobility, as most of us know, especially in its infancy, is not there yet. And I think when we talk more today about the software-defined connectivity, that it'll become pretty obvious that there's an opportunity here to help us all work on those margins once again. So thanks for having me here today.
And just thank you, Jeff. And just one comment I left off my introduction, and then I'll hop out of the way. We're also going to do a Q&A at the end of this presentation. So I just want to make sure that I remind everyone who's here today, thanks for being here again. And if you have questions, for any of our great panelists who just introduced themselves, please do drop them into the Q&A in Zoom, and we'll try to get to those at the end. I just kind of wanted to get the gears turning in everyone's heads in case they have thoughts they want to collect along the way. So I'll step out of the way now. Thanks, everyone.
Thank you so much, Luke. Yeah, feel free, guys, to write your questions. We'll do it in the Q&A session, or if during the talk there's something relevant, we'll pop it up. So my name is Itamar Kunik, and I'm the co-founder and CEO for Monogoto. And micromobility hasn't been my field at all. I'm a connectivity guy and a software guy. But in the last year and a half, I've been learning a lot about this industry and the underlying problems, the underlying solutions that can improve the way to profitability. And as Jeff mentioned, in an industry where margins are so important, where mistakes are really unacceptable, optimization is key. So what did I learn about micromobility in this last year and a half? So the first thing is that this market continues to grow. There are many challenges, there are many issues, regardless of consolidation and financial challenges that some operators or some companies are experiencing. This market continues to grow and continues to grow in multiple segments. We see mobility as a service or mobility as amenity, which is just picking up. The delivery solutions, like Tanya mentioned, that we'll discuss today, or even the consumer, where connectivity is just now starting. But we can all see a day when someone goes to a store, buys the consumer-grade light electrical vehicle, and has an app that allows it to unlock, lock, see the location. If someone mishandles the bike, you get a notification. Or if you want to allow your friend 1 day or 2 days access, you can just share the key via the app that allows you to access it. So light electrical vehicles continue to grow, and we can see that micromobility is here to stay, definitely. But there are so many challenges, as Jeff mentioned. This is such a complicated field. You guys know how difficult it is from the tech perspective, the operational perspective, the supply chain. So there are no room for errors, margins are slim, and optimization is key. So one of the things that we saw that happens with the consolidation is that companies are really, really looking forward into increasing their profitability. And what are the obstacles on the way to profitability? So you always have your usual suspects. In every vertical that Monogoto provides connectivity, we can see the usual suspects. And in micromobility, there's no difference. So it starts with high operational cost, labor, equipment, the unit economics, where you want to start small and scale, down to the level of vandalism and theft that can really hurt the bottom line, where you need to replenish your fleet and constantly monitor. But it's also from the competitive landscape. There are many competitors today. This is a very red ocean and not a blue ocean. So you constantly have to be differentiated. You need to make sure that the customer journey and the customer experience is top of mind. So what are the challenges that companies are facing? And Jeff, I want to turn this over to you. From your customer base, from your experience in micromobility, what are you seeing in terms of customer experience and brand loyalty? Where does this face a challenge today?
Yeah, sure. And I mean, really, this gets to the heart of the problem. I mean, I was talking kind of about the complexity of the systems in my introduction, but let's look at a typical potential micromobility client. Maybe they have bikes, scooters. They might have docks that provide locking capabilities and charging capabilities. All of these could have their own connectivity, whether they're IoTs in the vehicles and in the docks. They're probably or quite possibly in a city or another location with slightly challenged connectivity, whether that's GPS or cell, even in the best of times. And so if you look at this already complex system due to connectivity, and then you add in the challenges of a phone app, a rider maybe with some inexperience, the potential, the things that happen on the back end, and you could potentially for a new rider approaching a vehicle for the first time, needing to download the app, potential failure rates of 50% or more. And these aren't numbers I'm making up. These are actual numbers. And so when you think about that, a potential new rider or maybe even a seasoned one, looking at failure rates of that high, and what kind of message does that send when someone approaches a vehicle or a dock and can't unlock it or can't get through the app for any particular reason? And the answer is a big impact on the brand, likely that they may not try the particular brand again, may go to a competitor, and all of these things are fairly well known. And so when I think about the connectivity, one of the challenges in general with connectivity, it actually in many cases may be the issue for a rider, but not necessarily in all. But certainly in every issue, it's one of the first things that comes to mind. So even eliminating it as a potential issue can take time. So for me, all of this points to solving a connectivity problem or potential problem by either not having it in the first place or making it easy to diagnose or making it easy to roll out. It greatly increases the odds that a first-time rider or even a seasoned rider is going to be successful at unlocking a vehicle and leaving. And once again, when we think about the absolute razor thin, I mean, I say razor thin margins, and that's being kind. I mean, we've all seen what's happened in the industry the last year and a half. Any kind of margin is good news. And when we're talking about things like, insurance and labor and theft and vandalism, like we don't have any room for error. And so if we can improve our connectivity, the ability to diagnose connectivity, then we're increasing the number of successful rides, and obviously we're adding to our margins. And so that's extremely important area of the whole system.
I couldn't agree more. That's a great point. When a rider or someone wants a delivery bike and something doesn't operate properly, this loss of faith or the diminishing the brand loyalty means loss of revenue. So that also translates into some integration challenges. Jeff, did you guys what do you experience in integration challenges and the difficulties it brings?
Well, I mean, once again, I think that money solves a lot of problems, and I'm thinking back to my career in financial services where we had complex real-time systems, lots of moving parts, tons of data, things in the cloud, things on the edge. But once again, we had the money to work through all of those things. And so coming back to this business with margins, I mean, so much of this has to work right. And look, I'm in this business now, and because it's interesting to me, it's fun, and it's a big problem, and it's a great problem to solve. We have the connectivity, we have the vehicles, we have the docks, we have charging, we have gig labor. We have a phone app. We have ultimately the back end. There are all these moving pieces and parts that we're trying to operate by pulling a whole bunch of different teams, different vendors, scrounging where necessary on these margins to make it all work. So once again, coming back to any area where we can look at it and improve the reliability, improve our ability to sort of introspect quickly. I mean, I'm the CEO, and I'm on calls all the time where we're trying to figure out what went wrong with a particular transaction. Like I said, you think of all the ways, like connectivity. I mean, Stripe. There's just kind of an endless number of connections and integrations that have to work. Now, why are we having this conversation today? Well, because connectivity is one of the biggest ones, and one of really the first ones, and one of the ones, frankly, that a lot of us don't immediately think about. I mean, I don't have a background in cellular and communications and stuff like that. My background is more in making software and systems work. So if we can tackle one of the complex areas and feel comfortable that we have the tools to diagnose it, then why not? And that's why I'm excited about what we're talking about today.
Definitely. Thank you so much. Let's look at it also from the operational perspective. So Tanya, as the head of the supply chain, having thousands of moving vehicles around Manhattan, what were your challenges there?
That's a great question. So I'm actually really like this point about complexity, because if we divide these GPS tracking and IoT into two key components, like hardware part and software part, let's say that we have figured out the hardware part. So we selected the IoT device, which seems to us reliable and so on. And we used to think, at least I used to think, that software part would be pretty straightforward, and I would just send a couple of commands and the device would start sharing the data to our server. No, it doesn't happen like this in real life. This process is not straightforward, and it takes time. It takes time to figure out how to set up a SIM card, for example, properly. It takes time. It takes enormous amount of time to find a reliable connectivity provider in general, and even if you figured out the setup part, then you come to the realization that in any city there are areas with bad coverage, for example, and you just have no signal for your bicycle, and it's a very, like, it's a very frustrating feeling. Then you are looking at your bicycle with no data indicated, and you don't know what to do, because you have like zero data from this device, and it becomes even worse if any vehicle is stolen, for example, or if a customer refuses to pay because you don't have any means of taking this bicycle back or tracking this bicycle. So yeah, operational reliability is a great challenge, and you really need to be at least 99% sure, 99.5% sure that your connectivity provider is reliable, that you are having coverage all the time, and your uptime is up to 99%.
Thank you. What are your thoughts regarding costs? You guys are growing extremely fast and opening new places. Is this a challenge for you?
Yeah, for me, for us, cost-wise, the biggest challenge is that when you are getting a quote from a certain company, you're speaking about scaling, right? So we are providing the numbers, like our estimates on growth, and they usually reply that yes, the price, the cost will be reduced over time as you grow. But in fact, it doesn't happen, and so usually the starting point is quite expensive, but then you think, okay, so maybe as I grow the cost will be lower, but in reality it doesn't happen, or even if it happens, you need to put enormous amounts of effort into negotiating like every cent you agree on.
Understood, definitely. Thank you, Jeff and Tanya, for these points. I'm trying to combine everything and trying to see what are the underlying reasons behind these challenges. And I see first of all, as you mentioned, Tanya, the hardware and the software. The sensors, the IoTs are extremely more advanced today, and there are many options to choose from, and many good and reliable options to choose from. But we then realize that without the connectivity, it doesn't matter how good the sensor is if you're unable to speak with it, if you're unable to see what's going on or receive the events. So a lot of effort is going into the vehicle, the bike, the scooter, around the IoT itself. But there is a component that without it, we lose control and we don't know what's going on. And that is the connectivity part. Now, what I see is that more and more operators, fleet managers, they want to be in the driving seat. They want to be able to know and to see what's going on, to be able to react to events and automate processes. And that leads me to software-defined connectivity. So you guys are all extremely versed and familiar with connectivity providers. You take a SIM card from a vendor, from a network, you put it inside of your sensor, inside of your IoT. You need to configure it. Most probably you need to send some SMSs, or you need to configure it via data. the APN, the security, the IP address of your server, and start onboarding more. For example, if you've got a mapping solution, you need to call an API for that. So when we're looking on the difference between plain simple connectivity and software defined, there are 5 key topics here that are extremely relevant. The first thing is the self-service. As Tanya mentioned before, you don't want to be speaking with the operator every day, with the network, negotiate a cent here and a cent there, trying to understand what you're seeing, what you're not seeing. Everything should be given to you in a self-service way so you can view and optimize your fleet. But it's also with the APIs. Now, a tool with APIs is not a software-defined tool. Those are 2 different things. If you've got a platform that allows you to start a SIM and stop a SIM, that's not the equivalent of a platform that allows you to have a campaign that automatically onboards new devices. So you can react to the fact that you've got a new vehicle in your fleet, start calling APIs, doing firmware over the upgrade, a firmware over the air upgrade, and do everything automatically. So you want to bundle everything with modern IT and cybersecurity solutions, because at the end of the day, we want to make sure that our network is protected, that our devices is protected, and we want to react to all of these events. If a device loses connection, if a vehicle loses connection, we want to be able to know what's going on, when did it happen, what is the current status. And if we take all of that, we see that we have a lot of information, a lot of events. Not everything is for us to realize in real time. This is where a marketplace really comes in handy. So AI and machine learning to do predictive maintenance, to see if there are parts of your fleet that are misbehaving or that are not reacting similarly to all other devices. So you take all these capabilities, you bundle them with global connectivity. That means that the same solution, the same firewall rules, policies, IP addresses, automation, provisioning that works in one place will work exactly the same in another country on another network. So simplicity here is key, making sure not only that the device is connected. There are many global SIM providers, but you want to make sure that once you've done your automation, your firmware upgrade, your configuration, your cyber posture, those add-ons in the marketplace that gives you the AI, ML, predictive maintenance, regardless of the network or the physical location of the vehicle, you want to make sure that everything works the same. So all of that is on the public connectivity, but also this allows you to connect the same vehicles, the same devices on a private 4G or a private 5G network. We'll talk about it soon, but I want to also mention the nicest and the coolest thing we've got today, which is non-terrestrial network. So the world of connectivity is extending beyond public and private network into satellite-driven network, non-terrestrial network. So imagine a vehicle driving and connecting to AT&T or T-Mobile or US Cellular or Mexican networks or Canadian networks. It doesn't matter, everything is the same. When you are in your warehouse, in your distribution center, in your workshop, you can put a private network that will generate coverage and the vehicles will automatically connect to it. But if the vehicle is driving away from all coverage from AT&T or T-Mobile or from your private network, you can make a decision that says, let's switch to a satellite. It will cost a little bit more, just a few cents more, but I'll be able to send a heartbeat. Let's say if the vehicle did not transmit its location in 2 hours, I want to make sure that I use the satellite just a little bit more expensive, narrow bandwidth, so no real-time live streaming, but I can send a heartbeat and let us know for the fleet management where the vehicle is. All of that combined, this is software-defined connectivity, the ability to have a modern software-defined solution. So what are the benefits of software-defined connectivity when we're looking at micromobility? So Tanya, let's start with you. What did you guys automate?
Oh, so in order to set up a SIM card, you need to send to it certain commands. And what we used to do is we had a dedicated person in our team who was sending the commands manually, because there was just no any other way, no any other feasible way to do it. So as you can understand, first of all, it was taking enormous amount of time, and secondly, it was not the process wasn't transparent, because sometimes the command is not delivered, or it's failed, and your SIM is not configured, and we had zero clue that something is wrong on this step. So it was not transparent, it was not smart, it was not cost efficient. And currently, with the help of Monogoto team, we were able to automate this process. So what previously was taking sometimes hours because you were waiting for the reply from this particular SIM card, now is taking just 10 minutes and no human labor, no manual labor involved. So as soon as a SIM card receives power from the bicycle, the commands are sent automatically to the SIM card, and the bike is ready to go on the street literally in 10 minutes. And it was fascinating. The whole team, and especially this person who was sending the commands manually, were super happy and super excited to it. And also on a larger scale, also in terms of cost efficiency, for us, it just became visible which SIM cards are available, which SIM cards connected to the network, so we can be sure about this bicycle on the street, that if something happens, we are able to track it. And all this data is wrapped in one platform, and we can track the activation process and the current status of every single SIM card. So yeah.
That's awesome. That's really cool, and we were very happy to help you with that, and we can see how this really helped the industry. And if we take this even one step further, I remember one incident that we had, that you were seeing some bicycles that do not report their location, and you couldn't understand. You didn't have visibility to know what's going on, whether this is a connectivity problem or this is an IoT problem. So what did you guys do? What did you do with software-defined connectivity?
Yes, it's a super cool example as well. So we had a bicycle with no data indicated, and as I mentioned, it's really a very frustrating scenario. And previously, it wasn't possible to diagnose it, because the bicycle is somewhere on the streets in New York. It's not at our location, and we can't do any physical examination. We can't remove the device, reinstall SIM cards and the device, and so on. So currently, we are able to check the data the SIM card is sharing, and we are able to dig deeper in the pockets of data and see if the problem is on the level of the SIM card, or is the problem on the level of GPS antenna of the device. And we are able to withdraw some data from it and analyze and share with the engineering team. And so it gives us insane level of transparency and the understanding what is happening with this particular bicycle in this particular moment.
That was such a great example and a great scenario, because as the connectivity guys, we are always getting the first call. You know that you don't see the bike, you don't see the vehicle, but you don't know what's the reason. And this generates a lot of frustration, because I'm seeing connected, you don't see it connected. So one of the things that Tanya mentioned here, and they used our packet capture capabilities to look at that specific bike that they were debugging, and the bike is on the street. They have no physical access to it, but we are getting the support ticket that there is a problem. Working with Tanya and her team and our team, just doing a very quick packet capture, seeing the packet. So first of all, we know the connectivity is working, right? But at that point, we do not just say, okay, it's not our problem, can you please check elsewhere? Because once you have audit, once you have visibility, we were able to look at the packets going and seeing that the GPS coordinates that the device was sending puts it in the middle of the ocean. So at that point, Tanya and her team knew that they need to open a ticket with their mapping company, because data is there, data is being delivered and acknowledged, but they don't see it on the mapping solution. So it was so much easier in a matter of minutes to identify what is the problem and who's the culprit. Now, whether the mapping company wants to support a location on the ocean or not, it doesn't matter, as long as the customer, as long as the fleet manager, they know what's the problem. Yeah, so that was a very cool example. Thank you for sharing that. I also want to talk about the success rate, right? So Jeff, we mentioned before the importance of the success rate of connected devices. You mentioned up to 50%. Sometimes you are unable to communicate with the sensor, with the IoT. So what did you guys experience working with software-defined connectivity?
Well, I mean, I think that really we've seen failure rates of more than 50% for trying to start a ride, and I'm not trying to say that in all cases that's the connectivity, but it's always a culprit. And so software-defined connectivity allows us, as Tanya and you were just pointing out, to take a lot of unknowns out of the diagnosis really quickly. And diagnosing problems is hard, as we all know, and a lot of times it has to be done by our most expensive resources, people that would otherwise be working on new code features, et cetera. And so any amount of time that can be taken out of that diagnosis, pinpointing problems, of course, helps overall. But in general, the software-defined connectivity also enables us to connect more often as well. So it's not just a defensive sort of maneuver. It helps increase ridership in its own right. And of course, all of that drives the margins, which we know aren't necessarily great, and improves revenues, et cetera. And you know, another thing I'll point out, although we're not yet using it, the one of our a client that we're working with now has you know, some connectivity issues, and having a flexible software-defined capability that also incorporates satellite connectivity is going to be, well, not 100% a requirement, will allow them to implement more features than they're currently able to do. And so that seamless option, one where we're not really worried about it, it just works, is another big advantage for us.
That's a great point, Jeff, and I love what you mentioned, that it's not just a defensive play. So you are able to offer a better product once you have the software-defined connectivity, from the versatility of taking it into the satellite or to the private network. And let's touch on that. So Tanya, you guys reached out to us saying that you've got a location underground with no coverage, just no coverage. There's zero coverage of all networks, and you want your employees, your engineers, fixing problems and working, but being able to communicate with the device. So how did you guys use a private network, and where did it help you?
Yeah, so since we're speaking about cost efficiency, let's mention it once again. And in order to save some money, we usually rent spaces with basements for storage of spare parts, for example, or bike boxes. And in basements, there is zero coverage. So as far as you're in the basement, you don't have the access to any network. And for us, it's crucial to make sure that the SIM card is operational in the device while the bicycle is being assembled and still located at our warehouse. So we need they need this area to be connected to the network in order to verify that everything is fine with the device, and we can let it out to the city. So private network was a solution for this case, because it's surprisingly for me, we were able to set it up really quickly and easily, so it wasn't a pain. For some reason, I believe that it's very complicated, like, you know, some private network station which requires some engineering skills. No, it's like a kit that is relatively easy to install, and it provides excellent coverage. So any basement, we at all our locations we are now connected, and are able to perform all the necessary testing with the bicycles on site.
That's awesome, Tanya. And I think this is kind of one of the biggest misconceptions around private networks, that they are extremely complicated.
Yeah, to be honest, I first heard about them and I Googled them a little bit, that then it described by like long, complicated articles, and I don't see any real life application to it. But in fact, it's quite the opposite. There are lots of different cases that they can solve, and they are not that hard and challenging to install.
Perfect. So let's describe the scenario that we had with you. You can see a picture here of a unit. You can see the size. It looks very much like a Wi-Fi access point, but instead of radiating Wi-Fi, this just gives you cellular coverage. It's not a frequency booster. You're not taking an AT&T coverage or a T-Mobile coverage and you're boosting the signal. You're generating your own small cellular network. So this box takes two cables, one connects it to the electricity and the other one connects it to the internet. So, an Ethernet cable or Wi-Fi, just to connect it to your regular internet. And it gives you cellular coverage around it. So not only it generates coverage where coverage doesn't exist, the use case we had with you was very, very interesting also, because firmware upgrades, as we know, have low success rate. It's amazing to see how low the success rate is. But not only that, it costs a lot of money, because now you need to do for every byte the firmware upgrade over the air and pay for the data usage. So what you guys did, and here we have another example, is to utilize software-defined connectivity. So when the vehicle is on the private network, only then start the firmware upgrade. And if we combine this with the previous example that we showed about packet capture, now you get the visibility to actually see a firmware in real time being upgraded. So you generate the coverage where you didn't have coverage before, but from margins, success rate, and cost optimization, you offload all this traffic to your private network. Data doesn't cost money. So it doesn't matter if you're upgrading 1,000 bytes, 10 bytes, or 10,000, it doesn't cost more. But most importantly, it's an automated zero problem process. So the success rate is much higher. So thank you so much for sharing that. It looks like we're starting to converge. So I'd like to take a minute and look at what we saw so far, right? The impact of using software-defined connectivity has many benefits. So we know that connectivity is a must. There's no question. Without it, we're unable to remotely utilize our vehicles, monitor, control, etc. So we know we need connectivity. The question is, which one we will use? So one thing, if I'm looking at everything that we mentioned the increase in uptime and more coverage. And we know that that really, really helps for the customer experience and for the brand loyalty, which in turn, since Jeff mentioned, has a direct impact on your profitability and on your gross margin. We also mentioned about operational efficiencies, how you automate and you do proactive operation, predictive maintenance, but also cost reduction and cost optimization. You can offload data, you can generate coverage, but the most interesting thing to look here is how you're future-proofing yourself. We know that AI is taking a massive leap into all verticals, from insurance, driver behavior, roadside analysis, etc. We need to be able to support these more advanced use cases with battery behavior and battery management system, uploading a lot of information for battery optimization. But the last part is price. And it's important that your connectivity provider will know to scale with you, but also to shrink at some point in time, some months or some periods. Not all devices are active. You shouldn't be paying for what is not being used, and economy of scale should be a key consideration for your growth. So with that, guys, I want to go over to some questions. I see on our chat we have some interesting questions. I'll narrate them and I'll ask you guys if you can join me in answering. Some for me, some for you guys. So let's start with the first question. What is the difference in connectivity issues for stationary docks and e-bikes or moving or versus e-bikes moving around? So I'll take this one because outside of micromobility industry, we are seeing a lot of moving objects and stationary objects. Just imagine, guys, all around you, every street light that you can see, while driving has a SIM card, as an IP address, and receives firmware upgrades. Your smart metering, your electricity, your gas metering, all of these are connected devices that are stationary. And this question is great because people think, well, if this is stationary, I'll just take the easiest, most simple SIM card I can find in my pocket and I'll put it there. Where the contrary, we see many changes in the networks. It's a living, breathing thing. One stationary device can be connected today to a specific network and tomorrow not. The networks are constantly changing. The environment is constantly changing. A massive truck moving and parking in front of your building or your facility can really impact your reception level. So the concept in software-defined connectivity is to say we don't really care if the device is stationary or not. We will use the same logic and the same API to make sure that if you lose connection, you automatically and seamlessly switch to your other network. But also think about the stationary unit, for example, a docking station that goes underground. I don't have coverage underground, but we can utilize exactly the same private network solution we mentioned before, because when you have software-defined connectivity, you really don't care if this is a moving vehicle, if this is a flying drone, or if this is a docking station. It all utilizes the same platform with visibility and with APIs. So thank you for that question. Let's continue with some other questions. Tanya, you mentioned, I can see here that you mentioned that you were doing APN configuration, server IP configuration, your human process. What did it involve? Did you have to use third-party activation for new vehicles?
Yeah, so basically it was done manually. So as I mentioned, the person was manually sending these SMS commands via just his regular mobile phone, and it wasn't scalable, it wasn't cost efficient, it wasn't smart. And then we tried a couple of solutions, like for example automating these by some virtual numbers, so automated SMSs via third-party solutions. But the problem is that they can't really track the answer of the SIM card, because it's very important that the command you have sent to the device was applied to the device. That's like the key component of success. And with a connectivity platform, we are able to check the status of the SIM card. And so basically, now it's done by a script, by a campaign, which sends, as soon as the SIM card receives the power, it sends the commands automatically, and then it checks the status of these commands. And if they are not applied, it will resend them, and it will resend and resend and resend until everything is set up. So that's why, like initially, I was after we implemented the pilot of this automation, I was checking every SIM card manually to make sure that it's implied indeed. But now I can sleep, I can sleep and be sure that everything is fine, because it's checked by a script, and there are just no deviations.
That's a great point, and this is something we see a lot. That at the beginning, when automation starts, it takes time to gain confidence, because you're so used to doing things manually that people go in and check one by one. And I love the fact that at some point you sleep well at night because you know that the automation is bulletproof, and that's great. Thank you so much. Jeff, I see here a question for you. Are fleet management platforms going to offer connectivity as part of their solution? And what are the benefits of someone taking connectivity from the fleet management solution?
Yeah, sure. And I mean, the way we're working with clients, sometimes we kind of internalize the cost for connectivity and manage that process with a provider. In other cases, especially if it's an existing fleet, they might already have a relationship, in which case then we're only kind of a software provider. As we move forward, I honestly I prefer the first approach where we're able to bundle connectivity in with our offering. It enables us to have a standard that we can then deliver features to. So, and if you look at the wider world of computing and just in general the move to cloud, let's say over the last however many years you want to choose, 15, 10 years. Essentially what's happened is this idea about kind of, what do you put on the edge? So what do you put in your company, maybe in your own data center on your employees' desktop computers, versus what do you put out at Amazon or Google or Microsoft's Azure? And a lot of that comes down to where you need compute, what types of resources you have to be able to work on that stuff. And then the cost of moving data around, because it costs money to move data in normally out of big cloud platforms. And micromobility is really, no different. So now we have edge computing devices, which might be a phone app, it might be the IoT in the vehicle, and of course we have massive backends usually running in the cloud where we have capabilities. And as we look forward to the types of things that we believe we can do on the vehicles, I mean, one immediate application is something like cameras and video, and there's a lot of bandwidth involved. Do I want to send all of that over a cellular connection? Probably not. So what do I do with it when I get the vehicle back? If I have a private network, then it's a lot easier to tackle things like that. We can start thinking about AI applications, and we may want certain things to happen once again right on the edge. In the IoT, the IoTs are getting more sophisticated, but then once again, there might be a big data component. And so our ability to think ahead, develop these features that we know are coming, to make the trade-offs between edge computing, back-end computing, the latency requirements, all of this, if we have a software-defined networking and connectivity, gives us those capabilities. And so I do see fleet management systems, if not owning that level of connectivity, partnering very closely with providers who can offer that, so we can look forward to developing these advanced features.
That's awesome, Jeff. Thank you so much. Guys, we reach our time limit. I see some great questions which we'll take offline. I want to thank, first of all, the speakers here. Jeff, Tanya, thank you so much for joining us today. It was an absolute pleasure having you. Thank you for joining. And you guys, thank you so much for joining. Luke?
Yes, thank you all. That was really informative and interesting. I feel like we went really, really deep into sort of how connectivity can be a major driver of operational efficiency and micromobility. And it's a topic that I know is techie and in the weeds, but also incredibly important to our audience. And so it's good to be able to go really, really deep on it once in a while. So thank you all for lending your time and expertise here. Thank you all also for being here. Just as a quick reminder, Micromobility Europe coming up in Amsterdam on June 5th and 6th. You're going to see Monogoto. I know will be there. Hopefully we'll see Jeff and Tanya there too. If you haven't gotten your tickets yet, I have some exciting news. We're doing, I have one ticket to give away today, actually. So if anyone would like a free ticket to the show, a special kind of privilege for being here on a webinar, send us an email, info@micromobility.io. First person to email gets the ticket. So please reach out, and hopefully we'll get you a ticket to Micromobility Europe. And with that, I think that's kind of everything we meant to cover today. So thank you all for being here. Thanks for your time. Thanks for your thoughts. And if you want to replay this webinar anytime, I believe we're going to make it available as a recording. Yes, we are. So we're going to have a recording available, which we'll send around to everyone who registered. So if you missed anything, want to replay anything, we'll have it. Jeff, Tanya, Itamar, thank you so much for your time. Where can people find you if they want to find you?
So just go online to monogoto.io. You can get into our website. Feel free to reach out or come see us at any micromobility event. We are more than happy to start engaging with anything that you might think of connectivity challenges. We love supporting customers or anyone who just have some question about connectivity. It's our passion.
Jeff?
And
best place?
yeah, for me, the easiest ways to reach us on our website, that's GetRomer, ROAMR.com. If you'd like to reach me directly, it's Jeff, GEOFF, at GetRomer.com. Thank you.
And Tanya?
And for me, it's the website as well. So getwiz.com. And you can also reach out to me on LinkedIn. I'm Tanya Kashina, probably the only one. So yeah, feel free to reach out if you have any questions.
Great. Well, thank you all for your time. Thanks for your thoughts on this topic, and let's do it again soon, hopefully. Thanks everyone. Have a great rest of your day,
Bye-bye.
and see you on
Thank
the
you so
internet.
much.
Bye.
Bye.
Bye-bye.